These would normally cancel out because they're inverse functions, yes? 5 pi over 3 is not in my range. Why is it not in my range? Because it's larger than negative pi over 2 to pi over 2, right? It's 5.235. However, the black angle is 5 pi over 3. I need an angle that lies in quad 1 or in quad 4. Quad 1 angles are all positive angles. Quad 4 angles that lie in my range of negative pi over 2 to pi over 2 are going to be negative angles. Do we understand that? So what I need to do is to find my coterminal. But I need my coterminal angle to be negative. So I'm going to take my angle, and I'm going to subtract 2 pi off of it. If I subtract 2 pi off of that, that's the same thing as me subtracting off 6 pi over 3. 5 pi over 3 minus 6 pi over 3 gives me negative pi over 3. Okay? In other words, this angle right here is negative pi over 3 units. And that is the angle that I need to calculate. In other words, if I'm doing the sine of the sine inverse of 5 pi over 3, that's the same thing as me doing the sine of the sine inverse of negative pi over 3. Why is that? Because negative pi over 3 and 5 pi over 3 are what type of angles? Coterminal. And coterminal angles have exactly the same sine, cosine, and tangent values, correct? Okay? And negative pi over 3 lies within my range of my arc sine function. So therefore, now that I know that lies within my range, my answer is negative pi over 3 rather than 5 pi over 3. Do we get that, yes or no? Do we get it? Does that make sense? We good? Again, everything centers around this lovely little page. The arc sine, the domain negative 1 over 1. The range negative pi over 2 to pi over 2. Do we understand why I said you had to have a quad 4 coterminal angle? Yes or no? What I should add in there is that this is going to be a negative angle. I should add in there that's going to be a negative angle. The arc cosine. Do we understand why in quad 1 and quad 2 I'm okay and I don't need a coterminal angle? All my angles between 0 and pi would literally be a number between 0 and pi, wouldn't they? Quad 1 and quad 2 are my values from 0 to 3.14. Those are legit. That's why we do not need a coterminal. However, tangent, the same concept's going to apply here. My range is from negative pi over 2 to pi over 2, so I'm going to need my coterminal. And what type of coterminal angle am I going to have? A negative. Okay? Do we all understand that, yes or no? Okay? This stuff is what you need to have on your note card to remember about arc sine, arc cosine, and arc tangent. Can you tell me, arc sine, cosine, and tangent, what do those mean? What are you looking for whenever you use the arc sine, cosine, and tangent? What's the point of using those? What's the question you need to ask whenever you use those? When you use an arc, sine, cosine, or tangent function, you are looking for an angle. When you use an arc, sine, cosine, or tangent, you are looking for an angle. That's extremely important. Okay, how do I do this one? The tangent of the arc cosine of 2/3. This is the last one we left off with yesterday in class. Can tangent and arc cosine cancel out? No, they can't. So what do I have to do? You're going to let u equal the arc cosine, or whatever's in parentheses there, of 2/3. Now, does arc cosine actually have a value of 2/3? Is 2/3 in my domain? Is it a number between -1 to 1? What's 2/3? 0.6666666, right? So that's in my domain. My range is there an angle that exists that has a cosine of 0.66666? Okay? So we have to figure out how we can do that. Now, how do I get rid of arc cosine? How do you cancel it? With the cosine. So what you're going to do here is you're going to take the cosine of both sides. Do you see that cosine and arc cosine at this point, you need to check to make sure that 2/3 is what? Now in what? Before we asked, was it in our domain? Now I need to ask, is it in my range? Why do I need to ask if it's in my range? Because I want to do what to cosine and arc cosine? Cancel them out. So is 2/3, which is 0.666, in my range, which is from what to what? 0 to pi, is it? Yes, it is. So now I can cancel these out, and I'm left with the cosine of u is equal to 2/3. What does cosine mean in a triangle? Cosine means adjacent over hypotenuse. Do we see that, yes or no? So at this point, you can go right ahead and make your lovely little, I don't want that one. I want this one. Triangle. So I make my triangle. Okay? I'm going to put u right here. If u is there, where does 2 go? On the bottom. Where does 3 go? It is the hypotenuse. How do I know this? This is the hypotenuse being the longest side. This is the angle, the length right beside it. Right? Do we understand that? So how do I find my other side? Pythagorean theorem. This is a right triangle, so all I have to do is a squared plus b squared is equal to c squared. So a squared plus 2 squared is equal to 3 squared. A squared is equal to 9 minus 4. So a is equal to the square root of 5. Do we understand that, yes or no? So now I know this. So now I can go right back to my original problem, which is the tangent times the arc cosine of 2/3. Now what did we say arc cosine of 2/3 was? What did I say the arc cosine of 2/3 was? What did we let it equal? U. That's important, because now that means I'm doing the tangent of angle U. U is the angle in the triangle here. This is U. That's my angle U. So what does, that takes the place of theta in that, yes. Okay? So now, what does tangent mean in a triangle? I'm looking at a, what? Opposite over adjacent, thank you. So my opposite leg is going to be the square root of 5. My adjacent leg is going to be 2. That is the tangent of u. That is my final answer. This is just like problems 39 through 46. I don't care what you do, as long as you get the process down. There's a lot more online yet, too. That's the packet I passed out yesterday. You weren't here either? Sorry, Casey. Okay. Now, problems 31 through 38. Problems 31 through 38 is like the first example I did. Do we understand that? Okay? Now, I want to show you a couple things on the calculator. So I'm actually going to start your homework. Remember your homework was 4-7, 2 through 46 even. Now, problems 1 through 7. Number 1, the arc sine of 1/2. What does that read in your mind? What should you be translating this as? What angle has a sine of 1/2? Right? That's what your brain needs to read this as. Arc sine of 1/2. Every time you see an arc sine or a sine to the -1, your brain should be processing that as I need an angle. Now, the next thing your brain needs to say is, where is the range of sine? What quadrants is my sine answers allowed to be in for arc sine? So I am in quad 1 or 4. Do we understand that? Keeping in mind that quad 4, I need what? A negative coterminal. Now, with that said, arc sine being equal to 1/2, I'm looking for an angle whose sine is 1/2. Well, in quad 1, I have 1/2 square root of 2 over 2, square root of 3 over 2. Right? Which angle has the sine of 1/2? 30 degrees. So this answer is pi over 6. If I have it in quad 1, do I even need to look in quad 4? Do we understand that, yes or no? Part B, what's it say to do? What was it? The arc sine of 0. Which function between what? What's my range? From -pi/2 to pi/2. So can you tell me which function, which angle, has a sine of 0? Here's 1, 0. Here is 0, 1. And here's 0, -1. Those are where our zeros are at. So which one of those values has a sine of 0? What? What angle is that? Is 2 pi in my actual range? Do you understand that this is 0 degrees, which is also 2 pi, which is also 360. Your range is from -pi/2 to pi/2. You cannot use 2 pi or 360 because it's outside of my range. Do we understand that? So what is the only angle that I can choose? This has to be 0 degrees. Do we understand that? Or 0 radians, which is exactly the same thing. Any questions over 1 through 7? Do you understand what you need to do? Next, number 8. Y is equal to sine inverse of x. They say, consider the function y equals arc sine of x. And then they say, use the graphing utility to complete the table. So what we're going to do is we're going to pull up our graphing calculator. I'm going to add a new page. And I want a graphs page. Why do I want a graphs page? Because I want to graph it because I want the table, don't I? So if I do this, I'm going to hit trig. Do you see arc sine in there? What do you see? Sine to the -1, which is sine inverse, okay? I hit X, and I hit Enter. There's my function. Do we see it? I want to see it blown up. So I'm going to go to Menu, hit Window, and do Window Settings. What is my lowest X value for the arc sine? -1. And what's going to be my highest? 1. And what is going to be my lowest Y minimum value? -pi divided by 2. And then what's my highest? Pi divided by 2. And then hit OK. Now, there's your graph. Beautiful, correct? I need to fill out a table. Do I want to do all those calculations by hand? So what do I need to do? Hit Control-T to give me my table. By getting my table, I now can say, oh, well, wait a minute. It is not in my lovely little increments that I want it to be in. So what do? I hit Menu and go to Table and go to Table Settings. Where does my table start out in the book? A -1. And what is its increments by? 0.2. Okay? And then hit OK. What do these values over here represent? More specifically, they are numbers, you're right, but what do those numbers represent? Why are they angles? Because whenever you deal with arc sine, arc cosine, or arc tangent, you are always looking for angles. They're in what measurement? Radians. How do you know that they're in radians? Because they're decimals, right? Now, these are all what you're going to fill into your table. Now, if you are on your Inspire and you click up here and you go to Settings and go to General, if I go to Angle and hit Degree and hit OK, notice what happened. They went from radian decimal angle measurements to angle measurements that are now in degrees. So this is actually -90 degrees. This is -53 degrees. This is -36 degrees. Do you see that? And check out that the graph is still in radian measurement. The 83 and 84s do not do that. Do you understand that? Yes or no? We get that? The Inspires are the only ones that allow you to do that, which is a wonderful concept because my brain can deal what? Does it deal in radian measurement better or degree measurement better? Generally, your brain's thinking degree mode better, okay? You have to click over here and then click back on here because it has to refresh it. Now, if I come and bring my mouse over here, and I need to... Do you see how whenever you land your mouse right on that, it tells you what mode you're in? And it tells you according to what page you're on. So if I bring my mouse back over to that now, well, maybe it doesn't. It tells you that is going to be your general mode, okay? Not your geometry and graphical mode. So if I come back over here to Settings and do General and pull this down to Radian and click OK and come back over here, do you see that it changes it again? Puts me back into Radian. It's a very, very helpful thing. Now, that was Part A. Part B says to plot the points. Well, you plot them on a graph. Part C says to graph it according to this. You graph your hand plotted versus this and see how do they compare. They should all be the same, right? 8, 9, and 10 are exactly the same. 8 is the arc sine, 9 is the arc cosine, and 10 is the arc tangent. Do we all understand how to do 8, 9, and 10? We good? That brings us up to number 11. Love, love, love this. I want a new graph, and I'm going to do number 12, which is the arc cosine. So I'm going to hit Trig, cosine inverse of x, and hit Enter. Do I like the way that's viewed? No, so I'm going to go to my window settings, and I'm going to say my x minimum is going to be at what? -1 to 1, and my min 0 to pi, and hit OK. Now there is my cosine graph, my arc cosine graph. Do we get that? Here is the cool thing about the Inspire. Okay? Are you all listening to me? Bill, you better pay attention. Do you see on number 12 that they give you an ordered pair with a missing y coordinate or a missing x coordinate? Do you see that? Now for the x values, it's really easy, isn't it? Because you just plug and chuck. For the y values, you have to go backwards, don't you? So the Inspire users, if you hit menu and you do points and lines, do you see that you can do a point on? So put a point on, and then you're going to click on your lovely little graph. Okay? And then click. Double click it and it's there. You need to double click it and it turns it there. Now, you need to press escape to get off of that tool. Now, do you see that I have an ordered pair? I can double click on that ordered pair and change the x values. I can change the x values to be -1 and I can get pi. I can change the y values to be, let's say, pi divided by 6, and it'll give me my x value. Do you understand how nice and easy that is? Yes or no? Okay? That is a really sweet concept. The 83 and 84s do not allow you to do that. You have to use the table and go back and forth. Okay? Do you understand that? All right, 13 through 24. It says use a calculator to approximate the value of the expression. Very easy concept. I'm going to add a new page. I need a calculator page. And for 13 through 24, I want the cosine inverse of 0.75. I hit trig, cosine inverse, 0.75, and hit enter. There's your answer. For 24, I do tan inverse of 5.9 and hit enter. Do we understand that? Any questions over 13 through 24? 26. It says use a graph utility to graph f, g, and y equals x in the same viewing window. What it's asking you to do is to graph, let's say, the sine function. Sine of x. There it is. Then it's saying for you to graph the sine inverse of x in the same viewing window. And what I'm going to do is I'm going to change my window settings to be my window settings of which trig function do you think? Y sine inverse. You can see the sine inverse then, right? So I'm going to go from -2 to 2, and I'm going to do negative pi to pi. And the reason why I'm extending that is so that you can see the difference between the inverse and the cosine, and the inverse and the regular sine graph. Do you see that? Then I'm going to hit Control G again, and it says to also graph the x function. What do you notice? No. If you are inverses, back in the day, I showed you that the composition of them should equal what value? X. Which meant the graphs of those would be reflected over the line y equals x. Those are reflected. This inverse key reflects over, it folds right on top of sine. This part over here reflects over the line y equals x and lays right on top of the sine curve. Do we see that? I have showed you how to do every type of your problems except for 27 through 30. You guys should be able to have your homework done for me. Tomorrow I will not be here. You will have a recording over 4-8. Am I clear? I won't be here because I have IEP meetings all day. Am I clear? Have a great one.